Now, in a previous video, we covered how to create instance variables for a particular class object. In this video, we're going to talk about properties and the differences between properties and our instance variables. Now, in a nutshell, there is no difference. A property really is an instance variable. The difference is that we don't put properties inside of these opening curly braces. We actually put them down here as if we were going to do these functions. But the really nice thing about properties, and let's just create one and then I'll show you what's going on here. But if we go in, you start off with putting an @ property, and then you're going to put in the name of the variable that you want to create or the type of the variable first. So we're going to say that this particular property, now there is one thing that you need to get in a habit of doing. The first is that you have the ability to pass parameters into this property keyword. So what we normally do is we put in non-atomic, and this has to do with memory or with threading applications and stuff. But in most cases, non-atomic is what you're going to use. And then strong reference typing. And that basically is just telling the system that this class object, whenever we create an instance of it, it has a strong relationship with this particular variable, which means that we don't want this variable to get cleaned up or cleared out of memory unless this class does it, or unless this class goes away. We clean this class up and it'll go and take care of the variable. So it's just a good idea to put non-atomic and strong in here when you create properties. And then the next thing is the type of property we're going to create, and we're going to create an NS string, and we'll just call it a new username. So this is a pointer to an object. Remember, all classes, they don't contain the actual variable. They contain a pointer to the actual variable that's out on the heap. And then we'll create one more property just to do it here, and we'll say non-atomic and strong, and we'll do another string, and then we'll tell it that this is a address, let's say. So here's the difference between a property and an actual variable that we create like we did up here. You'll notice that on these variables, we actually had to come down here and create setters and getters so that we could actually get to the value of this variable, and we could set the value of that variable. In the case of properties, I do not have to do any of this stuff down here. It's done automatically for me in the background. So that gives me the ability on the interface to keep things very, very clean, because now the only functions that I'm having, or the methods I'm having to show down here, are the literal functions that we're creating to do other things. So properties are just a cleaner way to go in and have the system automatically do some stuff for me. Now, this handles the interface, but we still have to go and do something over here in the actual implementation of those variables. So remember, over here in the .h file, we went in and actually created the template, if you will, for what these setters and getters were going to look like, and we told it that the setter was always set, and then the all upper for the camel case username, and then this one was just the name of the variable, whatever, for the getter. So the system is going to do exactly the same thing here when we use this properties. That's why it's kind of important to name these things this way, so that if you do happen to use properties and instance variables, which you're perfectly capable of doing if you want to, that all of the variable names or function names and stuff will look the same. So when we go over here to the implementation, we actually came over here, and this is where we actually created the function that was going to be the setter and the getter for each of those variables that we created. Well, in the case of a property, I don't really need to do that. What I would do with a property is I would synthesize that particular property. So we called one of them new username, and then we could also do synthesize address. So what happens, just like over in the .h file, our interface file, it automatically created our setter and getter template files for us for the methods. Over here, it does exactly the same thing. So I don't have to waste time coming down here and writing a function out that actually is my getter and setter. It handles that for me just by typing this synthesize here. Now, this does not mean that I can't override the setter. Let's say that in this particular case of an address, I want, or let's say that we have another one called email address. So we'll change this to actually being the email address, and I need to change it over here. Email. So what is happening is I want to make sure that this is a valid email address. So instead of just setting it, I want to actually have it do some work. I want to see if it has an at symbol in it, make sure it ends in a .com or whatever it is that I want to do. But I want to make sure it's a valid email address that's being passed in. Well, I can still synthesize, which will go ahead and do my getter for me automatically, but then I can turn around and actually create a setter to be the setter for that email address, make it do some additional work, and it will override the synthesized setter that gets created automatically for me. So it gives me a way to take advantage of at least the getter portion being created for me automatically, and then all I've got to do is the setter. Now, if you're going to create a getter and a setter, then you don't want to do a synthesize or a property on that particular variable. Just create it as an instance variable and be done with it. So properties in the interface, synthesize in the implementation, and let the system do a lot of the work for you and keep your code as clean as possible when all you're really wanting to do is access those variables.